We go again on calculations involving density, mass, depth, and every other thing inclusive. And this one goes as follows. A test tube of radius 1.0 centimeters is loaded to 8.8 grams. If it is placed upright in water, find the depth to which it would sink, given that g, acceleration due to gravity, is 10 meters per second squared. Density of water is 1.00 grams per cubic centimeter. Options A, 25.2 centimeters, B, 2.80 centimeters, C, 28.0 centimeters, and D, 5.20 centimeters. A question like this is still friendly to handle only if you know how to go about it. First off, in our usual manner, let's get the data provided by the question. From there, we'll know the right formula to use. So the radius here, according to the question, is 1.0 cm. Okay, is heat loaded to the mass is 8.8 grams. So they're asking for the depth. Let me call the depth H. Okay, you can call it D if you want. Then the density is 1.00 grams per cubic centimeters. They also give G, but this G is just a distraction. I don't think it will be used in this question. Okay, let me just put it down. So they are asking for the depth. I must tell you that with this data that we've extracted, we still use our density formula. Density rho is equal to mass m over volume v. All right. The challenge here is that they did not give us volume, but they gave us some other things. And by dimensional analysis, we must know that mass over, okay, volume here, we must know that volume by dimensional analysis, volume is also equal to area times the depth. Why? Area is two-dimensional, while depth is one-dimensional. So making it three-dimensional like volume, okay? So for that reason, this formula will now change to m over ah, where a is the area and h is the depth, okay, at which we are to get. All right, now for us to get area, they gave us radius, and this is a test tube. So a test tube has a circular cross section. So for that reason, the area here, we can obtain the area A as pi r square. Okay, why? Because in a test tube is something like this. So it has a circular cross section here. So this formula is permissible to use for it. That's why I'm using area as that. Okay, so if we do this now, this would be pi is 3.14 or 22/7 times r squared, that is 1 square. So this will still leave us with 3.14 cm square. That is the area. Then we have the mass. It just for us from this formula, rho equals m over ah. We will make h the depth subject of the formula and we get our answer. So h will be equal to m over rho a. Yes, rho a. That makes h subject of the formula. So if we begin to substitute, mass is 8.8 over, the density is 1.00 times, the area is 3.14. So if we work on this quickly, our final answer will be 2.80. If we work on this, it will give us 2.80 centimeters, and 2.80 centimeters is option B. It is this simple to handle only if you know what to do. Thank you for watching. Remember to like, share, and subscribe to our channel.